do it. Alright, section 5.5, hyperbolas. Example 6. Here's our application problem. The design layout of a hyperbolic cooling tower is shown below. The tower stands 179.6 meters tall. The diameter of the top is 72 meters. At their closest, the sides of the tower are 60 meters apart. Find the equation of the hyperbola that models the sides of the cooling tower. Assume that the center of the hyperbola is the origin of the coordinate plane. Round final values to 4 decimal places. Okay, so you can look up some details about cooling towers that are used for things like radioactive power plant things. So because of the hyperbolic shape, mathematically, this shape allows it to cool faster because there's more surface area than if it was just a straight up and down cylinder. So it has to do with that. Alright, let's go to the actual assignment of finding the equation, right? That's what we're doing. Find the equation. So all of the details in here are in our picture already. Let's just double check those. So the tower is 179.6 meters tall. The diameter at the top is 72 meters. The closest, the diameter, the sides are 60 meters apart. We don't know this dimension because notice how this is not in the middle. So this is not also 72. It's going to be longer than that. This piece of the tower is 79.6. So take that out of the 179.6, and that tells us that this piece here is 100. Assume the center of the hyperbola is the origin. So right here is 0, 0. Let me narrow my pen for a second here. So this point right here would be at 30, 0. This point here would be at negative 30, 0. And then this point here, we don't know, right? We don't know the x value, but we do know that the y value is negative 100. And then this value here would be at negative x, negative 100. Alright, and then this corner right here would be at 36, because it's half of the 72. Right, so then the y value would be 79.6. So then this point here is at negative 36, comma 79.6. So the issue here is we don't know exactly where the asymptotes are. We don't know what B is, we don't know what C is, all we have is A. So A is 30, let's write that down. This is a sideways parabola, so that means we're going to have our x squared minus y squared. So let's go ahead and set this up with what we know. So we have x squared over 30 squared, so that would be 900. Minus y squared over, we don't know, we'll call it b squared, equals 1. So fortunately we have a bunch of points. These don't really help us much, but we do have these points, which are helpful because we have both the x's and the y's. So what if we took this point right here and plug it in for x and y, and then solve for b? That could be an adventure, right? Let's do it. So 36 squared over 900, 30 squared, minus 79.6 squared over, we don't know, equals 1. Well, how do we solve this? We're going to want to have one fraction on one side and then cross multiply. So one fraction on each side and then cross multiply, if that makes sense. So I think it would be easier to combine the 1 with this fraction, get that common denominator, and move this to the other side. I was thinking the other way around, but because this is negative, I can either do that or I can multiply the whole thing by a negative. I just want to get rid of that negative. It just helps make things a little less complicated. Alright, get out my handy dandy calculator. And 36 squared is 1296. Alright, so I'm going to have 1296 over 900. I'm subtracting the 1 from both sides. So I'm subtracting 1, but I'm going to write it like this. 900 over 900. And then I'm going to move this over there so that it's positive. So let me find 79.6 squared is 6,336.16 over b squared, which we don't know yet. Alright, so we've squared our numbers, we've moved things around, we can turn this into a single fraction over here now. So calculator 1296 minus 900 is 396 over 900. And then we still have this 6,336.16 over b squared. So then I'll cross multiply. So 396 times b squared equals 900 times 6,336.16, which is a big old 5,702,544. And we'll divide that by our 396. And we get 14,400, 0.36364. That is b squared. That is what we need for our equation. And if we really wanted b, we could square root that to get b. But our goal here is honestly just to write an equation. So we don't need to find b. B squared is good. So we're rounding final values to 4 decimal places. I think what I wrote down out of my calculator here is 5 decimal places, so we'll just cut the 4 off and we're good. So finishing up the problem, we have x squared over a squared, which is 900, minus y squared over 14,400.3636. Extend my fraction line a little bit there. Equals 1. And there's the equation for this hyperbolic cooling tower. So now the engineers know all the specifications and can use the equation to find all of the points that they need to build it correctly.